How was the first day of the conference? Did you enjoy? No, spoiler alerts. No. I surely did enjoy. And today I want to start with a topic which is very exciting and important for me especially, or the topic of identity. The next era of identity and data exchange. The internet was built without a way of knowing who and what you're connecting to. Nobody knows you're a dog on the internet. And when we have to do something really important, we usually don't use the internet for that. And this is because there is no trust layer from the start. Let me ask you some questions. Would you buy an apartment based solely on the electronic data presented to you by the seller? Or would you trust the Nigerian prince to transfer his 30 million worth of Bitcoin for 10% commission? I don't think so. What I do believe, though, is that the best of Web3 is yet to be built and embraced by all of us. And it has many names. Some call it Web 5, others decentralized identity, so-bound NFTs. But what it really is, at its essence, is the fact that you own your data. And it is not stored on a server somewhere anymore, but it's stored on your storage. And today I would refer to this as self-sovereign identity, or SSI. But let's take one step back. Why are we missing privacy, ownership, and control? Well, since the internet was built without a trust layer, this is really a big architectural hole from the start, and somebody had to fix this. And they did. We started building things that require trust, things like authentication with passwords, with single sign-on providers, certificates, SSL, X509, and these are all mechanisms for building trust. However, all of them are in the app layer. All of them rely on a central third party to control our identities and authenticate for us. And we need to move this away from the app layer and inside the internet itself by establishing common protocols as part of it. Because right now, most systems for authentication in the open web don't provide for mutual authentication with cryptography. They ask us to authenticate to sites and businesses. Nowadays, mostly the single sign-on integrations like login with Google buttons and so on. And in exchange for vouching for our security and providing ease of use, these companies receive valuable insight into our lives, into our commercial activities. And they often sell these insights. They use this data to control our choices. And I mean, it's terrifying to me. In some cases, Google knows me better than my mother. And I have willingly given my consent because I needed trust. So let me tell you a story. I really hate when I have to rent a car. Last time when I was in Mexico, I went to this counter in the middle of nowhere just to find a very criminal-looking man who asked for all of my documents. I gave him my ID card, my passport, my driver's license, my credit card, and he went missing for 30 minutes in the back just to make photocopies, digital copies, and who knows what more. And I couldn't help but wonder, why does he need to have all of my documents? Why does he need to copy, for example, my face, my birthday? Does he need to know my home address? I mean, he doesn't. All he needs to know is that I am legally allowed to drive a car in Mexico. And this example would look very different if we had the SSI protocols. First, I will have my paper credentials as digital ones inside my wallet. Then I can go to the car rental counter and authenticate mutually with the verifier, with the company. And when we have this peer-to-peer connection established, then they can request from me only the data they absolutely need to store. For example, my name. And even thanks to zero-knowledge proofs, I can also keep my privacy by proving to them that I have above 18 years, for example, without even revealing my birthday. And it is the same as if I ask you, are you Batman? And you don't need to present your Bruce Wayne identity to me. I can know and I can trust you thanks to cryptography. This really is a future I want to see, which is better for, especially for me, but for all parties actually, because it makes me the owner of my data. It puts me in control of how I exchange it, and also I can choose to be private, which leads to no data, or at least less data collection and data correlation. It is really better for all parties, and these parties are the issuer, like governments and trusted authorities that issue credentials to us, the holders, for us then to present to verifiers or the car rental company. And the biggest difference, the fundamental difference with this model is that we become part of the data exchange. Right now, with the central federated identity model, we are the only ones that are left behind. Issuers and verifiers exchange our own data without us even knowing. And with the self-sovereign model, we can finally be in the middle. We can be in the control, and we can have the power over our own data and identities. But really, this problem isn't new. It has been here for decades. And honestly, I really believe that finally it can be solved thanks to the Webtree movement, thanks to decentralized governance and consensus algorithms. And really, actually, Web3 was all about trust in the first place, even before the financial use cases, which are awesome. They created incentives to bootstrap everything. And now, just like how TCP/IP, HTTP, DNS shaped the internet back in the days, now we can establish a new set of protocols that enable digital trust and real ownership. And do you want to know the protocols? I really want to talk about them and discuss all the details that excite me. There isn't a clear winner right now, but yeah, right now I won't have time to discuss everything about them. That's why I've decided to just show you the fundamental architecture behind the new internet. The trust over IP stack. This is really the best mind map you can use to remember where protocols fit into. And since this is a blockchain conference, you might be wondering, where are the blockchains? Well, they are the first layer. The public registries. I like calling it the synchronization layer because it is used to store cryptographic primitives like public keys, and also the means to connect to each other, or the service endpoints, which we use then to connect on the second layer. But we all have many identities. I am very different here talking to you than I would be after, or when I talk to my family. So we need different identities for every relationship we have. And we store them here on the first layer in the form of decentralized identifiers. Then we use those decentralized identifiers to establish a secure peer-to-peer communication connection between ourselves. However, so far everything is public, the first two layers. But actually most of our data is private. My identity is private. So we need this third layer, or the means to exchange private data in the form of verifiable credentials and proofs. These are all standards that are being developed by organizations that bootstrapped the internet in the early days. And the final layer are the concrete applications and implementations using this tech stack. This really is the way to build technical trust. But every protocol, every layer and every protocol also needs political trust. This is why we have governance frameworks on every layer and in every protocol, which is another important part of building trust. So let's dive into the first layer. the important new concept we have here is the decentralized identifier, or a DID, which is a new form of URI, which consists of a scheme, DID, dit method, and a unique to this dit method string. The important part is really the method, because it represents the actual storage used to resolve and update the content behind this URI. And we have seen successful dit method implementations with Bitcoin, with Ethereum, with Cosmos, with Hyperledger Indy, and also we have Didweb, which is a traditional web server. And the same way, I can use an HTTP URL like google.com to, now I can use a DID inside my browser. And instead of receiving an HTML file, JavaScript files, I receive a DID document. And the most commonly used syntax for it right now is JSON linked data, which is the same as JSON, but with embedded links of external objects inside. So this really is our public identifier. And here we have to store two important attributes: the service endpoints and the public keys, as I mentioned. And in combination, I can look up your service endpoint in order to establish the initial connection with you. Then, by using the public keys, I can know that I am talking to you and not a dog. And yeah, here, as I said, blockchains are the best choice. At least I think so. But many people argue, why even use a blockchain when Didweb is completely sufficient? Why have this added complexity? And you all know the benefits of blockchains. I won't dive into detail, but if I have to choose one word to explain the benefits, I would use resilience. Resilience in terms that there is no single party in control, no single point of failure, the data is immutable, and even in the disastrous case in which we have a protocol governance failing and we somehow lose all of these properties, at least we will have verifiable history, which would allow us to prove that the credential was valid back in time. And because of the public nature of blockchains, the state transitions are verifiable. So a DID document's content can suddenly change without us even knowing. This really makes blockchains the best solution for a synchronization layer. Then we have the second layer, or our peer-to-peer communication protocols. Here, the two important new ones. Well, actually, OpenID Connect is not new. It's used all around the web right now, but it can be adapted for SSI usage. However, the more interesting one, in my opinion, is DIDCOM, which is a new enveloping protocol, which is transport agnostic, meaning that I can use it over HTTP, WebSocket, Bluetooth, email, anything. And also it supports custom workflows on top. So it is very extensible. This is the whole point of it. For example, the issuance of a credential is a protocol on top of DIDCOM, the actual exchange. And really, it is the basis of the new, more empowering internet. Then finally, we have our private data in the form of verifiable credentials, which is the standard. And we get the verifiable part by combining digital credentials with signatures. And following the example from early on, when the government issues a credential to me, the driver's license, they also sign this credential and expose their public keys to the blockchain. Then I verify and countersign, so that the verifier, the car rental company, is able finally to verify both of our signatures to know that the credential was valid. And there are really a lot of details about credentials. One important thing is that they're soul-bound, so they can't be transferred. So if I want to present something to the verifier, I have to use my credential to generate a presentation in which I decide what fields to disclose, or even use predicates and don't disclose anything. I'm very, very happy that this topic has started to emerge, especially the past year, and large companies have started to realize the importance of these principles, the principles of sovereignty, of decentralization, and they really are an enabler for use cases which are impossible with traditional technology. They have started, the large companies, to realize this. And I'm very excited to introduce Tim on the stage, who will provide the broader picture of how these protocols are actually used in the real world. Thanks.
Thanks, Martin. Hi, everyone. Martin just explained self-sovereign identity to you, what it is and why we really need it. I will focus more on the broader picture of things, so how we can use SSI in the real world. And we notice people usually understand this best by example, so we'll show you some use cases, one much more in depth, step by step, the other one's more on the surface. Also, I will talk about what BOSCH is actually doing in this field and what further possibilities are with SSI. So the first use case is a typical car rental use case. So we have a driver or a customer who wants to open a car, wants to close the car, wants to drive the car. And of course, we have the rental car itself. So in SSI terms, the driver would be the holder, here in green, and the rental car would be the verifier. Of course, in the system, we always have issuers. They're necessary, and this would be the car rental company, and we also have the driving license office from the government in here. So we have two issuers. So the driving license office issues driving licenses for you once you you passed your exam for driving. Of course, we also have the verifiable data registry, or in this case, two of them, and in the form of a blockchain. So we have a car rental company blockchain, which could be done by a consortium of car rental companies, and a government blockchain for government transactions and use cases. Now, in SSI, you write your decentralized ID and a DID document on these blockchains, so they're publicly available. These documents contain the public keys, which can be used to verify credentials. We also know that the verifier, the rental car, trusts the car rental company. After all, it owns the car, and the government. Now, the issuers, they issue the credentials. So they send them to the holder. They sign the credentials. So it would be the driving license and a temporary car key, since it's a rental car, and send them to the holder. Now, this transaction is written on the blockchain, but the credentials are never written on the blockchain. So there's no personal data on the blockchain. That's very important. Now, after this, the holder owns these credentials, probably in a smartphone wallet, and has the temporary car key and the driving license, and now can send this to the verifier, so to the car, as proof. So proof can consist out of different credentials or parts of credentials, so you only send what is actually needed for the car. Now, the car now can verify these credentials, uses the public keys of the issuers to do that. If it doesn't have the public keys already, it can look these up on the blockchains. But if it already owns them or if it already has it stored somewhere, this can also work offline at this point. Now, the verification also, this is really important, only happens between the holder and the verifier. So the issuers do not get any notice of that. It stays in between. Now, we have a couple of really big benefits here. We don't have the waiting at the car rental desk anymore, because you don't have to do personal identification or video identification. So you don't have to get your plastic card, your driving license, show it to the camera and wiggle it a bit, and then they can see the hologram, so they know you actually have this. You can the car does the verifying for the car rental company. Also a really big advantage is that you don't need a hardware key anymore to start the car. You can use your phone for this, so the car rental company could save costs. And there are also other possibilities, like this last point would be the car rental company could implement into the car that it limits the top speed, depending on how long you have the driving license, for example. In some countries, that's by law that if you have a driving license under 2 years, you're not allowed to drive more than, I don't know, 100 kilometers per hour, probably more. But you could implement this actually in the car, and the car would block this in this case. Many more things are possible. Now, for a completely different use case, would be EPSI diplomas. So EPSI stands for European Blockchain Services Infrastructure. So the EU is actually exploring what you can do with SSI and blockchains, how to make the EU benefit from this technology. And here, this would be for diplomas, of course, like the schools or universities would issue your final exams to your bachelor's degree, your master's degree, your A-levels to the people. In the EU, then, this can be used to do cross-border verification. So cross-country, you just go to another country and can show them and verify it, and as long as they're part of Europe, they can be completely sure that this is actually real. This has not been tampered with. This is not a fake bachelor's degree, perhaps. Yeah. You could tie the industry also with this. So that's the plan. That if you apply for a job with a company, they can verify your degree. So this makes application processes much easier, and you don't have all the documents anymore. Paperwork is much less. Yet another very different use case are mining permits. So this is in Canada. They have a lot of mines there. They have a lot of resources there, like gold and copper. They have tons of mining companies. And the British Columbia government, by law, they have to issue Mines Act permits. So these are permits so the mining companies are actually allowed to mine there. And these are always limited by time. So they have to reissue these all the time, depending on if they still are allowed to get that permit. Also, they do track CO2 emissions with this. So there are mining standards like towards sustainable mining. That's a certificate, and they can issue that to them. Now, the advantage for the industry here is that customers of the mining companies, if they want to buy copper from these companies, they can check, do they actually have a permit from the government, and do they follow the sustainable mining standards for CO2 tracking and limitations. So what are we as BOSCH actually doing here? We do a couple of things with SSI. First, we create and host organization wallets. We also created one. I will be talking about that later on. We host wallets for other companies so they can implement their use cases with SSI, so custodian wallets in a sense, but only limited to self-sovereign identity. We also research other real-world use cases. So we did pilot projects. One was hotel check-in with the German Chancellery and some hotel chains in Germany. So you could use your BOSCH employee card. We also have those plastic cards, and go to the hotel and basically sign in, and you didn't have to do a lot of paperwork anymore because that's necessary with hotels. They need all your documents. Now, another part where we are working in is Catena X. This is a consortium. This is an open data ecosystem from automotive companies. There are quite a lot of companies in there. This is mostly to track supply chains, so going from manufacturing to recycling, focus on cars. For example, you could track certain parts in a car when you produce it, and once it's served its purpose and you recycle it, you can actually get that part again, and you know from which company it was, when it was manufactured, and perhaps recycle it if it's still fine. We have an organization wallet. We call it the Business Partner Agent. And this is an open source, a self-sovereign identity organization wallet. We consider this an SSI Swiss Army knife, meaning it offers all the functions. You can be a holder, you can be an issuer, you can be a verifier. And then you can implement your use case using this wallet. So it's open source, licensed under Apache 2.0. If you want to check it out, you can follow the QR code. Some people are already doing this, nice. And go on GitHub. It's part of the Hyperledger umbrella project. They're also doing Hyperledger Indy and Aries and Ursa, which we are using. So it's quite a big community. Now, what are further possibilities for self-sovereign identity? Of course, we have the identification part, yeah. ID documents, passports, age verification. So if you want to buy alcohol in the supermarket, you have to prove you're an adult. So you have to show your ID card, but with self-sovereign identity, you could prove this without showing all the other unnecessary data to the cashier. But things like membership are also possible for clubs, hotel chains, and museums, like discount cards. If you're a member of the museum, you can go to the museum for free 5 times a year, things like this. They can also issue these credentials to you. Also ownership is a really big topic. You can certify that you own certain goods. And of course, we focus on the cars here. Like you know, if you own that car, you don't have to do the paperwork, in theory. Also, warranties are possible. They're usually limited by time. And usually, yeah, by 2 years, for example, you lose the warranty. Another really big area is the Internet of Things. We are exploring that very deeply. So human-machine interaction, smart contracts, and agents, meaning that machines can do business transactions in your stead. So your car, while you're driving it in the city, can book parking spaces for you by calculating, the best parking space and the costs for this, and actually do this transaction for you. Now, we hope that this makes clear that SSI is a very open system. It's not just an ecosystem for one specific domain. So not just between the driver and the car, or the government and a pupil or a student. This is all encompassing all areas. You can connect everything with this. So it's working more like a protocol. It's interoperable with other identity spaces. And that's really the key feature here. So we think it's the identity layer for the internet, and then it doesn't matter anymore if you're a person, an organization, a thing, or a dog. And remember, the best of Web3 is yet to be built and embraced by all of us. Thank you very much. We might have time for some questions.
Do we have time?
Or,
Hello. Extremely interesting presentation, Wows. And it's very interesting, this SSI thing. I have been researching it because it's quite new topic and not so well defined. And how did you implement it? I mean, from my understanding, SSI is something like a different network which is providing verifiable credential for someone who is already identified, and that's the base topic. Those verifiable credential. And my second question is, I saw that you use Hyperledger in the SDK to build your own network or just to connect to the sovereign network?
Yes. Okay, so regarding your first question, we are mostly building the standards that don't define concrete blockchains or wallets, but for example, the protocols for exchanging data in this manner. And this is again defined by the W3C Foundation, which is responsible for many of the protocols we know now. As for your second question, we are not using sovereign because, for example, when the government of Germany wants to operate a network, they want to be the one operating the actual nodes because this becomes part of the crucial infrastructure of the government, of the country.
If I might add something, the whole community shifts more away from Indy to areas, so to be a blockchain agnostic. I mean, Indy is really a great technology for this, but like the self-sovereign identity part is moving to the Ares project. So we have a lot of peer-to-peer connections. We still need a ledger for these transactions, for the public keys. That's really the biggest advantage of the blockchains. But we try to keep all the personal data in between the people, so they actually own it with them on their phone, nowhere else. Nobody can store it and correlate it. That's really the key part.
Thank you. And what is Iris, you said?
Aries.
Aries.
Yes, with A-R-I-E-S, yeah.
Thank you.
It's again a Hyperledger project, which was built together with Indy, but it was split from Indy in order to become more flexible and blockchain agnostic.
Fulfill those requirements which
Yes.
Webtree consortium have set for their model 1.3.
Yes.
Thank you for the presentation. I see a lot of benefits. It looks like a great technology, but can you talk a little bit about the possible threats, risks, or eventual drawbacks of this technology?
Well, I guess the beauty of it is we don't really find that many. I guess the biggest issue is making people acknowledge that it is there and to understand it, because it's tough to understand. At least that's how we feel about it. We, with the whole issue of verifier holder model, to make companies adapt. That's the biggest issue here. Yeah.
Thanks for the question. It's a hard one. I would just add that I think that the biggest assumption there is that you have to trust the issuer, because he is the biggest point of failure. So besides that, of course, there are some dystopian theories that people are not really fond of, but it's really up to the implementations, and since everything's public, you can always split and go on your own if you're not liking it. Okay.
I guess so, yeah.
We store our credentials on our phones or our devices. What's happening when we use it?
Yes, this is a big topic, and it's not for SSIs only, it's also valid for wallets. And honestly, I'm not an expert, but I think that social recovery is really the way to go, since...
As SSI, it depends on which flavor. There are different technologies, but the one we are using that supports revocation. So if you lose it's like you're losing your credit card, you call them and ask them to block it. So you can do this with SSI. Of course, they would have to revoke all your personal documents, but at the same time, it would be easy to issue a new one. You don't have to go to the government office and wait a couple of weeks to get a new plastic card. They can do this in seconds.
Revocation is one big benefit as well.
Haven't you talked about storing the actual credential on the blockchain encrypted?
That's a really big security risk, because you never know if the blockchain is still safe, like that particular technology in 10 years. It might be broken, quantum computers and whatnot.
There are some approaches doing this. Some people are using IPFS for this, but
yeah,
I'm not a fan of this approach, honestly. But yeah, we can discuss it.
Personal data should be with the people and the organizations. They also have an interest that other rival corporations cannot see that they actually have a business relation to another corporation. They can also kind of hide this, or others cannot snoop in and see. Like with NFTs and soulbound tokens, you can actually see who owns what. And that's the part we actually don't want. That's the main thing we don't want to do this. Yeah.
Okay.
All right. Thanks a lot.